We are live now. Good morning, everyone, and welcome to another session of Sustainable Saturday. Sustainable Saturdays are an initiative of Green Yatra where we choose different topics and we have our in house experts who talk to you about those topics, and they are environment related, they can be ecology related, many such fun, different, interesting topics. And for today's session, we have with us Jehu Nadar. Jehu is a social media associate and he holds a bachelor's degree in zoology. His primary interest lies in promoting native species, especially the much neglected freshwater ecosystem, to the wider audience in a simplified manner. And today, Jehu is going to be talking to us about this rather interesting, different, not heard of method called the Walstad method of aquarium. And इसका फोटो देखकर ही ऐसे लग रहा है काफी इंटरेस्टिंग है. तो जेहू, ओवर टू यू. आप समझा दो हमें क्या है ये वॉलस्टाड मेथड ऑफ एक्वेरियम.
Yeah, thank you, Sandra. And yeah, I'll be presenting a session on Walstad method of aquarium. Walstad method is it's not something. Not something new or something novel. Walstad method was developed by Diana Walstad, the lady you see in the picture, and she's a microbiologist. And if you go back to the aquarium hobby, 50 to the 50 years prior from today, you'll learn that aquarium hobby was not a uh, not a hobby for the common person. It was like hobby for the rich people, because maintaining an aquarium required high tech equipments, like huge filters, heaters, and carbon CO2 injections, those sort of stuff. And Diana here wanted to replicate a natural freshwater ecosystem in a tank. Wanted to go through, wanted to pass over this expensive stuff, and wanted to recreate a natural setting in a glass container, aquarium box, using the cheapest material available to her. And so she developed this method of aquarium which requires minimum maintenance and low cost components, and it's completely healthy for the living things present in them, both fishes and the plants. This system, it complements each other. The plants, soil, sand, and the fishes, everything works in harmony, um, uh, to contain this ecosystem, to make this ecosystem functioning properly. So that's the basic overview of Walstad method. Walstad method is basically nature trapped in a small glass container. And yeah, so let's go to the next slide. So basically, when I was a child, I used to see aquariums made by my cousins, like in their home, and this was the standard method which most of the people follow even now. Unfortunately, this is the typical example of aquarium which you most probably came across. So these are popular contents. The first one is intake pipe. Second, the numbers in the image are according to the numbers given in the left side of the image, like intake, mechanical filtration, 1, 2, 3, 4, 5, chemical filtration, biological filtration, medium flow, outflow to the tank. So, in the first case, fishes. Why do we need filters? Fishes are living organisms, and hence, when you feed them, they produce waste which needs to be disposed of, which because this waste, mostly in the form of ammonia, when left to accumulate in the water, can reach toxic levels of concentration and can kill the fish. So when I was a child, as I told you, when used to visit my cousin home, they used to have a huge aquarium with gravels, rainbow colored gravels in the bottom, pebbles, and water, of course, and fishes, and a mechanical filter and the aerator used to be an air stone with bubbles coming out continuously, agitating the water surface. So what's the logic behind the system filtration? This filtration system is still in use. Yeah, it's still commonplace in today's aquarium, but what's the logic behind this is that in through the intake pipe or the dirty water which contains the waste of the fishes and the unfinished uneaten foods, it's taken up by this inlet pipe, intake pipe, the pipe in the near the number one, and it passes through a mechanical filtration. Mechanical filtration is basically something which traps larger particles of waste, like poop of the fishes, which get trapped in the sponges. Mechanical filtration is basically sponge and sponge is kept in this container and water is passed through that container, water filled with fish gunk, and this gunk get trapped in there, and this sponges also have a large are porous, of course, and porous areas host beneficial bacteria which break down this ammonia into nitrates and nitrites. Nitrates and nitrites are not toxic to the fishes, but they, of course, they will be toxic in a larger concentration, but the fishes can deal with a lower concentration of them. And this sponge mechanical filtration, which is basically a sponge, is the standard filtration used present even today in the hobby. Even if you visit aquarium shops today, you will see sponges, black color sponges kept inside the water or like nearby the tank, which filters out the big particles of waste. And yeah, that's the only mechanic, that's the only type of filter I used to see in the air home. And next comes the chemical filtration. A few advanced filters will have chemical filtration. Apart from mechanical filtration, they will also have chemical filtration. Chemical filtration usually has like a carbon activated charcoal. Activated charcoal is extremely porous material which again hosts beneficial microbes, which again break down ammonia into the nitrates and nitrites. So and also uh, make chemical filtration clean the water not only of larger amount, like the bigger pieces of waste, they also deal with the smaller particles of waste. So uh, first comes mechanical filtration, and second comes chemical filtration in advanced filters, and the third one is biological filtration method, which is rarely seen in most aquariums, like in homes. But if you go to like people who are extremely interested in the hobby, like high tech aquariums, you can see that they have a separate canister filled with biological filtration medium. Biological filtration medium is uh, it's again contains something with lots of surface area, which can be suitable home to lots of bacteria, and this bacteria microbes, they break down ammonia again. And so, and after the water passes through all three of this, mechanical, chemical, and biological filtration, it's let down, let's like the clean water is again sent back to the aquarium through the outflow to the tank. The fifth number. So this is a basic representation of what a typical aquarium usually looks like. However, the most common aquarium you see in people's home, like in a layman's home, only contain most probably only contain mechanical filtration. The chemical filtration and biological filtration are like most probably absent. Only high tech aquariums possess this kind of filters. So
Okay.
uh, that's the basic logic behind the filtration method. We have to basically deal with the nitrogen, harmful nitrogen content present in the water, which is produced by the fishes. And another thing, in a typical aquarium, you will notice that this aquarium do not have plants in them. You can see plastic plants, which are pretty unsightly to look, and they also harm the fishes because they have sharp edges and the scales of the fishes are delicate. they can like tear, they can damage the scales of your fishes. So instead of helping them, it does the exact opposite of what we need. So let's go through the basic components present in this aquarium hobby. So first, I believe that you can see my cursor here. This
Yes.
black pellets. Yeah. Okay. This black pellets is what is called as aqua soil. Aqua soil is extremely pricey. If you like the as far as I know, it's like 300 rupees for 1 kg of soil. So
Oh,
with and it is just basically clay, which is shaped into small balls and heated to 300 400 degrees Celsius, and to retain their shape, to retain their form even underwater. Like this aqua soil is just clay balls, hardened clay balls, which can be used in aquariums. So normally what happens with the garden soil, if you put garden soil in an aquarium, of course you will end up with muddy water because the soil will mix with the water, because the fishes will disturb the soil, and the clay will mix with the water and everything will turn brown. Your aquarium will look like a puddle during the monsoon. So you don't want that. So that's why this kind of aqua soil is used. But and yeah, these soils do not contain any nutrient content in them, because nutrition content basically means ammonia, nitrogen. Like this soil is barely contains any nutrient. So you get a tank and you put this soil in them, and you put water in them, and put a few plants, live plants in them, and that's it basically with this aqua soil. Because uh, what happens when you put real soil, garden soil in your tank, that this garden soil will come with organic material which will disintegrate into the water, which will be decomposed in the water, and this decomposed material will release nitrogen in the water, which will harm your fishes. So the standard rule in aquarium hobby is that whenever you soil is used in aquarium, you we make sure that fertilizer or any kind of organic matter content is very low. So because if you have high organic content in your soil, the it will be quickly decomposed, and all the nitrogen content, ammonia nitrates will increase in your tank, and it will wreck your fishes. So that's the basic idea behind this. But this is very expensive, and it is like overhyped stuff in the aquarium hobby. Like overhyped. Every people will pay lots of money to buy this kind of soil, which is nothing but clay balls, hardened clay balls. And second is fertilizers. As I mentioned right now, that this soil is basically devoid of any nutrient content. Will be what like but we do need nutrients for the plants to survive, right? So what do we do is that we use liquid fertilizers like the one you see in this bottle right here, or we use root taps like this one. This liquid fertilizer you can pour directly into the water. Of course, you need to measure the concentration before introducing it into the water, or else it will damage, it will harm your fishes. And root taps are basically, as the name suggests, like root. You take one of the like you take the required amount of these tablets, and you basically insert it near the root of the plant under the soil, and what this tablet will slowly disintegrate, and this the nutrient present in this tablet will be available to your plants. So cause this we need to do this because in high-tech aquarium, basically you do this stuff in this high-tech aquariums, because this soil does not have any nitrogen content, because we do not want nitrogen content in a high-tech aquarium, because nitrogen will wreak havoc on your fish's health. So that's the basic logic. If you use this, you will have to use this too, either of these two. Okay. And the third one is, this is a heater. Yeah, please.
so in spite of
uh
they're using the pellets that you have pasted the picture of, उसमें तो artificial
hmm.
plants जाते हैं. And even then, will you have a requirement for the fertilizer?
No, no, artificial plants are not used in high-tech aquarium. Artificial plants are usually seen in Indian homes, in Indian home
Okay.
aquariums. I'm talking about a hobby standard, the industry standard, the standard materials used in aquarium hobby. Mostly in
Okay.
high-tech aquariums like the one you see here, like you can see here, like those are real plants, not plastic plants. And
Okay.
yeah, yeah, this soil is basically nutrition deficient, and so we will have to feed this taps and liquid fertilizer occasionally to keep this, to help these plants grow. And so heater is normally not used in India because we are living in a tropical country. But if you live in a temperate zone, then the fishes, if you want to keep tropical fishes, but you live in a temperate country, then you will have to use these heaters. Here these heaters have built-in like sensors in them that will maintain the temperature in whatever range you give them. So not really that important for us. We basically live in Mumbai, so Mumbai is a coastal city, so the temperatures usually don't fluctuate that much. And yeah, the next thing is CO2 in carbon dioxide gas. As you can see, the thing is that in an aquarium, we plants require CO2, right? Plants require CO2, and fishes produce CO2. But the thing is that fishes are not kept in a large amount. Like fishes, we don't overstock fishes because fishes are expensive, and fishes like lots of room to survive. They like to explore your tank, and so it's generally recommended to keep this livestock very low in an aquarium. So what happens is that if you want to see fast plant growth, you need plants need carbon dioxide to grow faster, but we also want to make sure that the fishes are healthy and happy, so we keep lower amount of fishes. So the fishes do not produce enough CO2 to satisfy the plant's need. So we will have to artificially introduce CO2 into the water. So this is a CO2 canister, like, and this pipe goes to this pipe, and it slowly diffuses into the water. The CO2, CO2 gas slowly diffuses into the water, and this CO2 gas is used by the plants plants to grow faster. So in combination with this CO2 gas and like a high-tech light like this, aquarium light like this, the plants will be growing like crazy. So that's the reason for most people would have never heard about CO2 canisters used in aquarium. Like it will be like something yeah. Even when I was introduced to this kind of stuff, I thought that this is contrary to what we want. We want a oxygen rich water for the fishes to survive, but why do we need to introduce CO2, which is like contrary to our interests, which can harm the fishes? But yeah, this CO2 will not harm the fishes because as you can see, it slowly diffuses into the water, and most of the CO2 actually escapes out of the water surface. So only a few percentage of the CO2 gets dissolved in the water, and they are quickly used by the plants. Because in aquarium we have artificial lights which can be kept on, which are usually kept on for 6 to 8 hours. Recommended time is like 6 to 8 hours. So for 6 to 8 hours, the CO2 and light work hand in hand to to keep the plants happy. So the fishes do not get generally do not get bothered by it, and also we keep the concentration. We consider the concentration of CO2 while releasing it into the water. So this these are stuff which you see in a high tech aquarium. So, and this is a aerator. Aerator is basically something which will like agitate the water surface to promote the mixing, to promote the gas mixing in the water column. So aerator will not aerator does not introduce oxygen into the water. The function of a aerator is to agitate the water surface so that the air present in the atmosphere will get dissolved into the water. This aerator will not introduce any air uh, into the oxygen into the aquarium, contrary to popular beliefs. So And this is the filter I was talking to about, the high-tech filter which we use. One of this canister contains mechanical, chemical, and the last one will contain like biological filtration material. So this is one like example of high-tech filter. And yeah, aquarium lights are another expensive things, and one of the expensive thing, like we have specially made lights which emit light in the blue and red spectrum, like 700 nanometer and 400 nanometer, like 700 for blue, and red for 400 for red colored lights, because plants generally use light in this two wavelengths to like induce photosynthesis. So we have specially made lights for working in this specific wavelengths, and they are like pretty expensive. Yeah. So this is what's the industry standard, the aquarium industry standard. And Diana wanted to get away from all of this stuff. She wanted an aquarium which can take care of it itself, like what happens in the nature. We do not clean lakes, we do not clean ponds, unless of course we mess it up by pollution. But mostly we do not interfere in a natural ecosystem, and the ecosystem survives happily without our help. But and Diana wanted to replicate this in her like aquarium. She wanted to keep an aquarium she can set it up for one time and she can forget about it forever, like. Oh, so that kind of approach, and she also wanted to replicate to reduce this artificial stuff like CO2, filter, light, what and what not, aquarium spoil, fertilizer tablets. So she didn't want this artificial stuff. So she worked on it for quite a few years before coming up with our method. We will see it quickly. Okay, so yeah, as I mentioned, nitrogen cycle. This is the only thing which you need to consider while setting up an aquarium. The thing, nitrogen cycle is like fishes eat food and they produce ammonia, and also decomposing plants which have overgrown and like diseased plants, when they decompose they also produce ammonia. And the soil, as I mentioned previously, the reason we do not use the high-tech aquariums do not use nutrients rich soil is because this soil contain organic matter which can decompose and introduce ammonia into the water. So ammonia is bad for the fishes. Fishes don't like ammonia. So what happens is that a filter will contain Somonas sort of bacteria. No need to get particularly detailed here. So these good microbes will deal with the ammonia and convert it into nitrites, and again these nitrites are converted into nitrates by another group of microbes, which are used by the plants. And ammonia is directly used by the plants. And when you do a water change, you remove the nitrates from the system, and when you feed the fishes, you introduce new nitrates into the system. So if you don't want to do this water change, what you need to do is let's the answer is right before your eyes, like here. Plants take up nitrates, and plants also take up ammonia. And Diana, what she found out that when compared to she took a control and fish tank with ammonia and plants, and a fish tank with nitrites and plants and sort of stuff, and she did an little experiment to find out that plants generally prefer ammonia over nitrites or nitrates. Like plants will only feed on nitrates when ammonia is not present. Okay, so their plants first preference is ammonia. So if you don't want to use filter or you don't want to do water change, your answer is right here. Like plants will deal with the ammonia for you, for the nitrogen for you. So yeah, as I mentioned, Walstad method is a way of maintaining aquariums naturally, holistically, with minimum maintenance. So These are examples, some sort of example, like some examples of aquariums like here. So you can see this is a small glass ball, usually like easily available in a store, and you can see that here, like the bottom layer is covered with dark, it's like in the dark shadow, so you can't see it. But you can see the soil here, like you can see the soil, I guess, in the
Yes.
below part, and it's capped with sand and lots of plants. The basic logic here is soil, and soil is covered with sand in order to prevent the soil from mixing directly with the water, and lots of plants, lots of plants with little livestock. Livestock can be shrimps, any aquatic animal. Like the number of plants should be higher compared to the livestock. So you can see in this aquarium, like there are like hardly any three or four fishes here. Like I can see one, two fishes here. But the plant life is like there's a diversity of plants there. You can see that these guys are heavily planted. The size of the container or the shape of the container doesn't matter. All you need to do is just follow this simple method, like soil, sand, plants, and low amount of uh, livestock. So let's go
Interesting.
through the components of, yeah, let's go through the components of Walstad method. The first thing is substrate. Contrary to the what I told you previously, like we do not use nutrition rich soil in aquariums, cause nutrition rich soils will introduce nitrogens, harmful nitrogen, which can damage your like parameters, water parameters. However, in Walstad method, we use nutrition rich soil. You use garden soil,
Okay.
basically garden soil, normal soil available in a garden. uh, yeah, but make sure that it does not contain any like contaminants like for fertilizer, pesticide, those kind of stuff, because so take some good quality soil, and 1 inch of soil, spread it evenly in the aquarium, like you can see in this representation, like 1 inch of aquarium soil, and cap it with sand. The sand should be at least 2 inches, and I would recommend more amount of sand, like 3 inches or 4 inches. The more deeper, the more deeper, like the more sand layers you put, the more stable your aquarium will be. Because when you introduce fishes like borrowing fishes, or some kind of aggressive fishes like cichlids or those sort of stuff, they love to like dig around the sand and pull the plants out. So when that happens, there's a danger of soil mixing with the water. So and the more amount of sand you have, the more balanced, the more stable your aquarium water parameters will be. Like the sand will be the breeding ground of good microbes. So the more amount of sand you have, like the more amount of microbes you have. So it's like directly proportional. So, and plants, diverse selection of aquatic plants. You want as much diversity as possible in aquatic plants, because aquatic plants are brutal. They like they will compete for highly with each other. If you it's up to you, like the plant selection is up to you. You want, if you want to replicate some kind of stuff like with certain plants, you can go for it. But yeah, but the more diverse the plants are, like the more number of plants there are, the more better it will be. The fishes should be like very low. You don't want lots of fishes. Lots of fishes means lots of food, and lots of food means lots of nitrogen, which we don't want. And also fishes generally like when the aquarium is not crowded. So lighting low to moderate intensity. If you do not have actually natural sunlight is best, but if you don't have natural sunlight, then you can use artificial light, LED light, any kind of white color LED light, and the intensity should be low, because if you keep the light in high intensity, then there is there is a chance of algae growing, outbreak having algae growth will be more in intense light, at least for the initial few weeks. The Please keep the amount of light low. Once the vascular plants, like the higher order of plants, this bigger aquatic plants get their hold, and they are good. When they start to grow faster, you can keep the lights, the intensity of the light, you can keep it higher. So because by then the plants have established themselves properly, so they will be ready to compete with the algae. Filtration. The filtration we use is of on plants and substrate. The substrate is home to microbes which will convert ammonia to nitrate, and the plants directly feed on ammonia as well as nitrates. So this is the only filtration which we'll be using. If you want to keep extra filtration, it's up to you, but then that will be no longer called as Walstad method. Water changes, as I told you, the maintenance is bare minimum in Walstad method. You don't need to do any water changes. If you want, if you feel that you really need to do it, then you can do it, but generally there is no need for water changes at all. So the steps and how to set up it. Yeah. Substrate setup: first layer it out with soil and cap it with sand, then plant, and then fill it with water gently to avoid disturbing the substrate. And after 1 week, actually 1 week, keep an eye on the water. Notice any changes, any bad smell or plants dying, those kind of stuff. If you see any bad sign, then please hold on. Don't introduce fishes. Wait until it sorts of the problem will sort of on its own, but please hold back the fishes before introducing any fishes. You can introduce snails, hardy. They are very hardy snails. You can introduce. So fish introduction should be very careful. You don't want to introduce fishes and then watch them suffer and die. Light, yeah, as I told you, low to moderate light for the initial few weeks to avoid algae. Monitoring, continuously monitor and adjust water parameters and those sort of stuff. We'll learn it as you keep on going it. Sure, let's so watch this 1 second 1 minute video, and which I did.
Wow, that looks beautiful, Jehu.
Mm. Yeah, so that was the mini pond I made in our office. So you can find the link. I'll put it in the description. And yeah, the maintenance part, as I told you, it's like bare minimum. You need to trim the plants when they some plants are very aggressive, so you need to cut them back. They will, or else they will dominate the other plants and they will kill them. So you need to keep them in check. So you need to prune those sort of plants, and constantly monitor, observe your fish behavior and health. uh, if your fishes show any sign of distress, then please do whatever is necessary to keep them happy. And algae growth is not the danger of algae growth is present initially for the first 2 weeks or first 3 weeks. After that, once the tank gets stable, you never will have to face the problem of algae. a little amount of algae is like preferable because algae is not something harmful to your aquarium. Algae is a natural thing present in water, so don't stress over it over a little amount of algae. And yeah, monitor water parameters regularly. If you like, you can get kits which can measure measure out the ammonia level and nitrate level online. So you can buy those kits and measure the concentration yourself.
What are
Yeah,
those kits
benefit.
called and where can you find them?
Yeah, sorry.
What are those kits called? What do I search?
Yeah, yeah. You can search like a water parameter kits for aquarium. You will be getting pH also, pH indicators also along with that.
Okay.
Like yeah, phosphate level, nitrogen level, those kind of basic parameter stuff we can test.
Okay.
Yeah, and benefits of Walstad method. It is Walstad method is mimics natural ecosystem. It's like a replica of nature present in your living room or wherever you keep your aquarium. Like soil in nature, you will notice that soil and then sand and then water, plants, fishes is usually seen in a uh, pond or lakes. So we replicate the same stuff in this aquarium. And yeah, there is no need for any fancy equipment like CO2 canisters, filters, uh, expensive stuff like LED lights, if you will. Yeah, this stuff, the emulsion method requires the bare minimum to maintain an aquarium. Yeah, and the third part is that all the living things, biotic and abiotic factor present in the tank, work in harmony to balance each other out. Like fishes give food to the plants, and bacteria and plants keep the water clean for the fishes. Like yeah, so it's a win-win situation for everyone. Points to remember: there is no hard and fast rules regarding freshwater aquarium hobby. Like I mentioned previously, like that if you want to add a filter in Walton method, it's up to you. You can add it. You can modify this method uh, as much as you want. In fact, Diana Walstead method, which I just now taught you about, is not purely the one which was Diana herself thought. Diana told to cap the aquarium, the soil with gravel, or because gravel, the pebble size are larger, so there are large amount of spaces between the rocks, the pebbles, so that the fish, the fish gunk, the fish poop gets travels to the soil. So like what she recommended was that 1 inch of soil and 2 inches of gravel. Gravel is pebbles.
Right.
However, like in the last 20 years since she published the book, we have learned that using gravel is not that great. But sand, especially river sand. River sand is like the grain size of a river sand is slightly like significantly larger than what you find in the sea, in the beaches. So don't use beach sand from the beaches. Use sand which like slightly larger grain sizes. So so those sort of sand will have enough spaces for the roots of the plants to breathe. So keep that in mind. You can modify this method as much as you want. There are no hard and fast rules. No one will like judge you. Don't use high flow. It will like yeah. If you want to replicate a river in an aquarium, don't use Walshad method. Walshad method replicates ponds and lakes, not rivers. Rivers will not have soil in their substrate. Rivers do not have plants also. Rivers rarely have any plant in them. So if you want to replicate high flow water flowing aquariums for your lochas, hill stream lochas, those kind of fishes, don't go for Walshad method.
Okay.
Use a proper filter and high flow motors to do that, or else you will be making a mess. Stock low, always stock low amount of fishes, living things. The fauna part, the flora keep it high, the fauna keep it low. Like even in nature, if you will notice that the entire lake is not filled with fishes.
Yeah.
The fish, yeah, fishes are present like the tiny amount of lake. Fishes like lots of spaces. Check for hitchhikers before introducing for yeah before introducing anything into the aquarium like soil, sand, water, plants, anything or fishes for themselves. Please look for parasites or anything which can harm the harm your fishes or plants. Parasites and bugs like dragonfly larvae will be hitchhiking along the plants and those sort of stuff, and they can significantly deal a big huge damage to your fishes. So
Oh.
do that properly and do not introduce borrowing fishes. A few fishes are present which like to borrow deep, and these fishes will borrow away the sand and they will reveal the soil to the water column and your aquarium. Like I had experience with I kept two albino catfishes which dug through the sand layer. I actually made a mistake of capping it up with only 1 inch of sand. So what happened is that this catfishes they like to burrow among the the sand. So they burrowed their way into the soil, and in 2 or 3 days the entire water turned brown. And I was too lazy to clean it, so I had to keep those catfishes for 6 months in murky waters. I couldn't even see them, nor could they see me. Yeah, so you don't want that to happen. So plants. These are like few example of plants which you can keep. So yeah, Diana like highly recommends keeping floating plants. Lots of floating plants. Because what happens is that floating plants have direct access to the carbon dioxide present in the atmosphere. So these plants will grow faster than the completely submerged plants. So what happens is that when these plants grow faster, it means they are like sucking up the nitrogen in the water. They are using CO2 from the atmosphere, but the nitrogen they are using is from the water column. So your aquarium will be clean of nitrates or ammonia faster by using this kind of floating plants like duckweed, water lettuce. It's up to you. Like this section,
Okay.
keep a lot of them. Yeah. And livestock you can keep anything and everything except yeah keep don't keep fishes which are known to pull away pull drag out the plants, uproot plants.
Okay.
So on and don't keep burrowing fishes like me, like that catfish which I kept. Like, you don't want the fishes to disturb the substrate. But if you uh, cap the soil with 4 or 5 inches of sand, if you want to, then you can keep any kind of fishes because no fisher will dig that deep. No fish will dig 5 inches of sand. So
Okay.
yeah, that's it from me. Thank you.
This is very interesting. I actually, in fact, before this session, I really did not even know that you could make an aquarium without having anything with you at all, like those filters that we normally see, etc. So. This is complete new information for me, and I'm pretty sure it is a lot of new information for our audience as well who is watching this. So, thank you so much, Jehu, for this session, for teaching us about this very interesting, innovative method of maintaining aquariums. And thank you, audience, for attending this session. And we will see you.
Thank you.